Hi everyone. In today's video, I will be going over the Q1 benchmark study guide for Precalculus. So this video, I am going to show you all the cheat codes, the hacks to get through these problems as quickly as possible with as little pain as possible. So that means I'm going to use my graphing calculator as much as I can. There's a lot of graphing calculator things I'm going to show you should already know, and then a few things you should know, but if you don't know, hopefully you will after you've seen it. So, make sure you have your graphing calculator handy and make sure you're able to type all the things in that I am about to show you. First question, which equations represent the graph? And which equation represents the graph? We have three options here. So you'd want to graph this carefully. Graph them one at a time. So we have square root of x minus 2 plus 5. Graph it. A dead giveaway that this is the wrong one. Notice on the actual picture here, this starts to the left of the y-axis. It does not do that in here, so A is not correct. Let's try B. So it's x minus 2 minus 5. Let's try that. One, it's still to the right of the y-axis, not to the left, because this is the y-axis here. Also, it's kind of hard to tell, but this is the x-axis here, and notice here it's below the x-axis, so again, that's not it. So it has to be C. Let's go ahead and graph it for good measure. Alright, I don't know what I did. I think I messed up something, but I just checked it again. This is the correct graph. It didn't look right for a moment. Okay, C is correct. Number 2. Identify the multiplicity, even or odd, of the graph at, and then we have 3 places to look. So at positive 2, so let's go to positive 2 on the x-axis. Reminder, if it's even, it bounces. The graph bounces. And a bounce looks like that, where it curves. If it's odd, it goes through. So if you have a point, the line goes straight through it. So if we're looking at 2, it goes through the point. So this has odd multiplicity. Negative 2, make sure you look carefully here, also goes through. It's odd multiplicity. 0, it bounces. This has even multiplicity. How I kind of remember this, I don't know why this works for me, but like there's like 2 lines here. 1, 2, I don't know. And 2 is an even number, so that's how I can remember that evens bounce. But you have to remember even bounces, odd goes through. So when we give you this, that's what we're asking for. We're not asking is 2 an even number. We're asking for the multiplicity at that number on the x-axis. So those were the 3 points we were looking at. Number 3, we're still using this graph, is the inverse of this function a function, using the graph from number 2. So if you remember, this has to do with the horizontal line test. If a function passes the horizontal line test, that means the inverse is a function. Don't confuse it with the vertical line test, which tells you whether or not this graph is a function. So this graph does not, it clearly does not pass the horizontal line test. Here's one such example. Hits 1, 2, 3, 4 times in one line. Since it fails the horizontal line test, then this is not, the inverse is not a function, no. So use the horizontal line test here. If it fails the horizontal line test, that means the inverse is not a function. Number 4, identify the inverse of the function. The inverse of the function is where we take all of these points and we flip-flop the x and the y values. So it'll look like this. Negative 2, 4. 0, 10. 7, negative 22. Running out of room. 8, 3. And negative 1, 17. Negative 2, 4, 0, 10, 7, negative 22, 8, 3, negative 1, 17, C. So notice these last three, they didn't take a lot of work, but I really can't use my calculator either. They're just kind of knowledge questions, unfortunately, but pretty quick problems still. Number 5, determine whether the function is increasing, decreasing, or constant on the given intervals. You want to read this one very carefully. I remember this was one of the biggest struggle points for us with that first test, was the intervals. So reminder, these are intervals. So this is not the point -1, 0. This is from -1 to 0 on the x-axis. So first off, these are x values only. So kind of think of this like domain almost. And then remember, -1, 0 is from -1 to 0. That's what we're looking at. So -1 is right here. So we're looking from -1 up to 0. So right now that's where we're looking. From -1 to 0, what's this graph doing? From left to right. It's going up. Going up is increasing. Zero to 0.8. Make sure you're looking closer there because I almost made a mistake. So now I'm going to do this one in green. So 0, that's this here, to 0.8. I almost thought that was this, but I believe that's this, which it wouldn't have made a difference on my answer. So 0.8 is right here. And then 0, it's going to overlap with the orange. That's okay. Remember, intervals of increasing and decreasing, they very much overlap here, or at least they'll connect. So that's this here, what I did in green. So from the left green to the right green, what's the graph doing? Follow it. It's going down. It is decreasing. Once more, I guess we can try pink. I'll do it in red. We'll see how this goes. 0.8 to 1. Very small interval here. So the 0.8 is the end of the green. I changed my mind again. We found my red pin. So 0.8 is where the green stops and the red starts. And then to 1, which I'm kind of struggling to even see where this is. I'm going to kind of judge by the distance here. I assume that's going to be past here. Can't really see that very well, unfortunately, so I'm kind of doing some educated guessing. Again, it wouldn't change my answer if I chose this point or to the right of the line. My answer would still be the same. So from 0.8 to 1, we can see if we follow the graph, it is going back up. So it is increasing. So there were no constant intervals here. Reminder, constant is where it's perfectly straight. There's no increasing or decreasing. We didn't have that here, so nothing to worry about. Okay, number 6. Determine the domain and range of the graph. This is a quadratic. You can assume that these are arrows. And domain of a quadratic is -infinity to positive infinity. The graph that we do see is perfectly solid. There's no gaps, jumps, or holes in the graph. And then this arrow while moving down is also moving left. And this arrow while moving down is also moving right. So this domain will be completely covered. We just can't see most of it. Range is the y values. Again, we look at this from bottom to top. So we start down, pointing down. So we start at -infinity on our range. And then we follow it up. And the graph stops at -2 on the y-axis. So it's -infinity all the way up to -2. Graph stops. There's no more graph after that. This gets a bracket since -2 is a solid point here. And that's it. Next page. Seven, describe the end behavior for A, f of x equals 2x to the fourth minus 220x plus 7. So to do this, you look at the leading term here, 2x to the fourth. So you start with the exponent. You ask even or odd. This is even. Then you look at the leading coefficient, positive or negative. This is positive. So even and positive, that gives us up and up, meaning our graph is going to roughly look like that. On the left and the right, it goes up. So I don't even need to pay attention to which x, because both sides go up. So it goes to infinity. But if we do care to break this down, x approaches positive infinity, this is going to the right. Because if it's going to the positives, it's going right. X is approaching negative infinity, that means it's going to the left, to the negatives. But since these ends both end up positive, it doesn't matter that I didn't really pay attention to which direction. B, f of x equals, again, find your highest degree, which should be at the front if they're not out of order, and they're not. So negative 12x to the 7th. Start with your exponent. 7 is odd. Leading coefficient is negative. So odd tells us it's going to be a disco. And then negative, so your options are disco left or disco right. Negative is left is a negative movement, so disco left. And then how we know this looks, disco left, if you remember the disco move, the arm that is up is in the name of the disco. So this would be like your left arm being up in disco. Also, if you think about it, the disco left, this has a slope that gets negative as we move across the graph. So it starts positive, but it ends negative. So negative is how it ends, but it doesn't start. So if it ends negative, it starts positive over here, since we have one of each. I hope one of those hints resonated with you. So here we have, as x approaches infinity, that's to the right, because the positives are on the right. So as x goes to the right, so this is where you want to cut this picture in half. The right side is pointing down to negative infinity. So f of x goes to negative infinity. That's where the graph is going. So then, as x approaches negative infinity, the negative numbers, the left side of the graph goes to positive, because it's pointing up. On top of that, if this is something that you struggle to remember, I have news for you. You can graph this. Now, no promises. I don't know how much of this is going to show up, because some of these are extremely large numbers. But it is possible. Hopefully we can see something. Oh, wow. Okay, I don't know whether I should zoom in or out. This is kind of crazy. So we can see that it went down and then back up. So for this, I just graphed the first equation. So if you watched it closely enough, you can see that these are both pointing up. I will try to zoom out to see how much we can see, but I don't think we'll be able to see much. We can watch it graph again at the very least. Yeah, so it was up, it went down, and then it came back up. So, yeah, that was a little rough. Hopefully you get the picture. And it won't let me leave. Yeah. Up and up. Kind of hard to see, but it makes sense now that we know it's supposed to be up and up. Now this one I'm afraid we won't be able to see, but let's give it a shot. X to the 4th plus 7x minus 30. Okay, so we saw it come down, meaning it started up. And then I'm going to zoom out to make sure it doesn't go anywhere else to the right. But it should go down and then just keep going down, essentially. Yeah. So you kind of saw it jump up and then keep going down. So this is disco left, just like we classified it. Unfortunately, we give you some pretty complicated polynomials to make it hard to tell by the calculator. So if you can remember your types, that's what's best. Remember, even and positive is up and up. Even and negative is down and down. And then if you have odd, you have a disco. Negative is disco left. Positive is disco right. And so, like to the left or to the right. So then the other one would be going the opposite direction. Hopefully that helped. Number 8, I'm going to, actually, I don't have to do this on paper because it's multiple choice. Use synthetic division to find f of -4. F of x equals 3x to the 4th minus 9x squared plus 100x plus 2. So, if you want to do synthetic division, be my guest. Or, you just plug it in. 3 times -4 to the 4th minus 9 times -4 squared plus 100 times -4 plus 2. 226. The answer is A. Now, if you set up the synthetic division and solved, your remainder should be 226. And remember, this is how we would check our answer. But again, on a multiple choice test, this is the level work you have to do to get the answer. Number 9, write the equation in standard vertex form by completing the square. Remember, we just call it vertex form. In vertex form, completing the square. If you have not already figured out this tip, I mentioned it a few times. A very easy way to figure out which one works. These represent the exact same graph. So this and then whichever answer is correct, they represent the same graph. The equation is just in a different form. It makes it easier to graph. But these are not different equations. So the graph that overlaps itself is the correct answer. So we're going to graph the original, 2x squared plus 4x plus 13. And then I will just go through the options. So 2 times x plus 2 squared minus 11. Don't make a mistake. Very easy to do. Oh, hold up. I'm going to have to fix the zoom in a moment. Okay. Well, as you can see, these are not the same graph. These are two different graphs, so A is not my answer. Let me adjust the zoom here. Your zoom should always be in zoom standard. That's the typical look that we have of the graph. So just an FYI if your calculator is messing up. And actually, it was good that I zoomed out because you couldn't even see the other graph. Okay, so that was not it. Let's fix this. So let's delete this 2. X plus 2 squared plus 7. I have a feeling it's going to be C because I feel like that 2 still needs to be out in front, but it could be wrong. Plus 7. And delete. Okay, this is correct. Graph. Now I know where the other graph is because I've already seen it, so I know this isn't right, but let's zoom out. When you zoom out, you have to click on it. So click on that, and you have to hit enter again when you get to the graph to actually zoom out, just an FYI. So there's the blue graph, that's the one that's my original graph, and then they're supposed to overlap, so the red is still wrong. So C is correct. But let's just check, just to make sure. So I gotta redo this. 2 parentheses x plus 1 squared plus 11. Now these should overlap because I've pretty much narrowed it down. This has to be correct. It's going to trace right over it in red. There we go. You see that? That means that that is the correct equation because they're the exact same graph, just a different form of the equation. So that's how you know when you are right. So C is correct. 10. If the roots are 4 and -2, find the polynomial of least degree. I can also use my calculator for this one. So what this means is that our roots are x equals 4 and -2. Remember, roots means x-intercepts. So what they want you to do with this is they want you to write these as factors, x minus 4 and x plus 2. Because when you set these equal to 0, you got 4 and 2. Multiply them together and get your equation. Not that this isn't hard. This is hard. It's not hard, but I know some of you might get to this question and you might forget how to do it. How to do the math is actually pretty easy. But if you forget, you forget. So you want the graph that has these two roots. So that means the graph crosses through 4 and -2 on the x-axis. So let's graph those until we find the right one. So let me clear out both of these. x squared minus 2x plus 6. So we need to have 4 and negative 2. I'm going to have to zoom back in. This clearly is not it because it doesn't even touch the x-axis. So this graph doesn't even have any roots. Yeah. It's not A. Let's try this one. Minus 2x minus 8. Which this should be the correct answer. Negative 2, positive 4. That's where it crosses. Just for good measure, let me show you that C is incorrect. So that has a plus 2 instead of a minus. That's x squared plus 2x minus 8. It flip-flops. This one is negative 4, positive 2. So the numbers are correct, but the signs are wrong. So you have to pay very close attention there. So that is wrong. Very close, but wrong. And that's it. Number 11, unfortunately, no calculator here. Simplify 6 plus 2i times negative 4 minus 3i. So we just FOIL. Okay, 6 times negative 4 is negative 24. Negative 3i times 6 is negative 18i. 2i times negative 4 is negative 8i. 2i times negative 3i is negative 6i squared. So you have negative 24. 18 and 8, that would be 26, and this is a negative 26i. And then negative 6 times I squared is negative 1. So now we have negative 24 minus 26i plus 6. Combining, finally, 6 and negative 24, that should be 18 minus 26i. Sorry, negative 18. This is negative 24, positive 6. Negative 18 minus 26i. And that's it. That's our answer. Number 12. Find the vertical asymptotes, horizontal asymptotes, and holes, if any, and graph. So this one, we don't have to do all of the steps outlined on the paper because it doesn't ask for it. So this is where we would need this paper here, and we need to go through the first 4 steps. So factor if you can, find your holes, your asymptotes, graph it. That's all we have to do. So definitely want a piece of paper because we obviously do not have that kind of room here. So for number 12, f of x equals x squared minus 3x minus 18 over x squared plus x minus 6. So step 1 is to factor. And that comes from the paper. So we want to factor this down. So let's factor the top and the bottom. So we can factor the top. We have our 2 x's. And then we want 2 numbers that multiply to 18 that will give us a negative 3. So right off the bat, I can use a combination of 6 and 3. Notice we have a negative 18, meaning one of these numbers is negative and one is positive. And we want our final answer to be negative 3. That means 6 has to be negative and 3 has to be positive. And on the bottom, make our factors. So we have our x's. Now right off the bat, 2 factors that come to mind are 6 and 1, but there's no way I can get a 1x from 6 and 1. I'm either going to get 5 or 7. So 2 and 3, I can get a 1x. Since it's a negative 6, that means I have 1 negative, 1 positive. Since my middle term is a plus 1, I need plus 3 minus 2. Multiply, you get negative 6. Add, you get positive 1. Now notice that I can cancel x plus 3 from the top and the bottom. This will create a hole in the graph at x plus 3 equals 0. So at x equals negative 3. Now remember, a hole is a singular point, but it's an open dot on the point, meaning it's not actually defined there. So this right now is a line. We need the actual y value that goes with that hole. To find it, we're going to plug it into our new and improved equation, x minus 6 over x minus 2. You can try plugging it in here. It's not going to work, which is why it's a hole. You have to plug it into the new one. So we have negative 3 minus 6 over negative 3 minus 2. Negative 3 minus 6 is negative 9 over negative 5, so 9/5 is the whole. That's the y value. So our whole is at negative 3 and at 9/5, which I will get that as a decimal. That should be 1.8, but I'm going to check. Yes, 1.8. Okay, now let's find our asymptotes. First, we start with the vertical asymptote. I'm just going to abbreviate that VA. You get that by setting the denominator equal to 0. And you do that with the new one. So it says after dividing out the wholes, set the denominator equal to 0. So x minus 2 equals 0. So at x equals 2, we have our vertical asymptote. And then the horizontal asymptote, we go by the original function. Yes, by the original function. And we look at the exponents. So remember, we call the top one in the numerator n and the bottom one in the denominator m. These both have an exponent of 2. Since they have the same, we use the second case in this box here, n equals m. If we have that, then we use y equals a over b, where a is the leading coefficient on top and b is the leading coefficient on bottom. So we're doing case number 2. Y equals a over b. So let's go back up to our function. Again, the original one. The leading coefficient here, a, it's a 1, and b is also a 1. Find the highest exponent, term on the front, it's a 1. So y equals 1 over 1, or just 1. So our horizontal asymptote is y equals 1. I believe that's all we were asked to find. Vertical, horizontal. Yep, okay, so now we graph. So we don't have to go into a ton of detail here. So I'm going to start with my asymptotes. Or actually, yeah, why not? Let's do the asymptotes first. X equals 2. So positive 2. And then y equals 1. And then we can now plot the whole, negative 3 and 9/5, which is just 1.8. So we go. Man, I did not plot this very well. Okay. Negative 3 and then 9/5. So if that's 1, we'll call that 2. The whole would be like right here. For the rest of it, you would just want to grab your graphing calculator. Reminder, when you graph this, you want to graph the original function. If you graph the new and improved function, the wholes, anything like that, that will be taken out. The original function is what you use to get the full picture. So we have x squared minus 3x minus 18 over x squared plus x minus 6. And then we wait. Looks something like that. FYI, if you weren't able to find the whole, unfortunately it wouldn't show up in the table because it's an error message. So that would be at negative 3. See? Error. So you can kind of guesstimate where it would be at, but you want to get the exact number. So just an FYI. And then we have an error on 2 because of the asymptote. So we're going to keep this to a very general graph here. I won't plot 3 points, but reminder that is the typical expectation, is that we plot 3 points. So something like that. And then, again, just kind of freehand it. Something like that. Check. Number 13. I think we do the same thing. Yep. So that was number 12. 13, find the vertical asymptotes, horizontal asymptotes, and holes, if any, and graph. So let's do that. What's really important on these problems is identifying all of the things. The graph is the, above everything, the least important part of this problem. Just an FYI. We want to make sure you're able to find all these things. F of x equals 6x plus 5 over 3x minus 2. So first step is to factor. And there's nothing to do here. Can't pull out a number from the top. There's no factors of 6 and 5 besides 1. They don't both have an x. Same thing with the bottom numbers. So there's nothing to do here. Step 2, look for holes. Well, if we can't factor, we don't have any holes, so none. Step 3 is the vertical asymptote. That's when we set the denominator equal to 0. So 3x minus 2 equals 0. If we add 2 over, we get 3x equals 2. X equals 2/3. So our vertical asymptote is at x equals 2/3. And then our horizontal asymptote, that comes from comparing the degrees. So the degree of the top here is 1, and so is the degree of the bottom. We just did one of these. That means if n equals m, we use y equals a over b, which are the leading coefficients of our terms, of our numerator and denominator. So here the leading coefficient is 6, and here the leading coefficient is 3. So y equals 6 over 3. So y equals 2. That is our horizontal asymptote. Make sure I'm not missing anything. This should be it. Yep. Now I graph. Again, we're keeping it very light, very general here. So our vertical asymptote is at 2/3. So if that's 1, I'd call 2/3 right about here. Yeah. And then our horizontal asymptote is at 2. Y equals 2. To get the rest of the graph filled in, you just need your calculator. Graph 6x plus 5 over 3x minus 2. Yep. And then just fill in the shape. Reminder, if you were doing this by hand on an actual test, would definitely expect you to go to the table, pick out 3 points, and graph them. All right, that was number 13. I think we're, at the moment, done with graphing. That'll be a nice break. Number 14, write the polynomial function with zeros, x equals 5 and x equals negative 2i. You will definitely want another piece of paper for this. If you haven't caught on pretty much anything that requires or involves imaginary numbers, you cannot use your calculator. Number 14. So zeros, otherwise known as roots. So this is a roots to equation problem. We've already done one of these on here, but I was able to do it in my calculator because it was all whole numbers, all rational numbers. That's the word I'm looking for. Rational numbers, real numbers. This one I can't do in my calculator. And I don't have any choices either. That was the other thing. So we start with our roots. X equals 5. X equals negative 2i. Now, if you remember, I have to include a root that's going to get rid of the I in my equation, and that's its conjugate, which is the opposite sign. So that's a positive 2i. So I have to include this root in order for this to work. That's the first step, and if you forget about it, obviously your answer is going to be wrong. So now we create factors, well, first we set them equal to 0. So we just move all of these over to the left side. X minus 5 equals 0. X plus 2i equals 0. X minus 2i equals 0. Now we make our factors, so that's where you create an equation where these are the factors. F of x equals x minus 5 times x plus 2i times x minus 2i. And then we multiply together to get our equation. That's it. Reminder, you can multiply in any order. I recommend multiplying these together because these are a difference of squares. The middle terms cancel out, which is why we end up without any i's. So bring down the x minus 5. Multiply the fronts and the backs. X squared minus 4 I squared. Reminder, I squared is negative 1. So when I rewrite this, f of x equals x minus 5 times x squared. This is negative 4 times negative 1. So this is x minus 5 times x squared plus 4. Last but not least, I have to FOIL these two together. X times x squared is x cubed plus 4x minus 5x squared minus 20. Last but certainly not least, you have to have it in standard form. That is just how we write our equations. X cubed minus 5x squared plus 4x minus 20. And that should be all of it. Yeah. So I'll write that down as my final answer. F of x equals x cubed minus 5x squared plus 4x minus 20. Even if you are given answer choices, you'd have to be very careful here with just using your calculator. You more than certainly need to do this one by hand. 15, simplify 5 minus 2i over 1 plus 4i. I will try to keep this on the paper. So reminder, when you divide, and I say that lightly, complex numbers, what you're really doing is you're trying to get rid of the I on the bottom because you can't keep that there. So what we need to do is multiply this by its conjugate to get it off. That's when you use the opposite sign on the I term. So it's 1 minus 4i, and we do that on the top and the bottom of the fraction. So then we multiply. On the top, we fully FOIL. 5 times 1 is 5. 5 times negative 4i is negative 20i. Negative 2i times 1 is negative 2i. And then this is plus 8i squared. And then on the bottom, these are a difference of squares, meaning the i's will cancel. So we have the fronts multiplied, so that's 1 minus the backs multiplied, 16i squared. Now this is just 1 minus 16 times negative 1, because again, I squared is negative 1. Again, this is why we do this, because we no longer have i's. Simplifying the top, we have 5, negative 20i and negative 2i is negative 22i, plus 8i squared is 1, so 8 times negative 1. Here we have 5 minus 22i, this becomes minus 8, and then 1 plus 16. 5 minus 8 is negative 3 minus 22i over 1 plus 16 is 17. And then the proper way to write your final answer, remember it needs to be in that a plus bi form. We want, if we have fractions, to make them into two separate fractions. So you have negative 3 over 17 and then minus 22 over 17i. That would be your full final answer. Next problem. 16. List the possible rational zeros, p over q. Find a zero using graphing calculator and find others using synthetic division. Graph the function. A lot of stuff by hand here. So I will need a separate piece of paper for sure. Number 16. This is that stuff that we did on the P's and Q's notes. That's all of those notes that we did. So the P's and Q's. On top we have the factors of our constant, 42. And then the Q's are the factors of our leading coefficient, so 4. Oh, and apparently we have to do domain, range, and end behaviors. We've got a lot of stuff we have to list. So 42, 1 and 42. Then we have 2 and 21. And then I believe 3 goes into that. 3 does go into that. 3 and 14. Let me check that. Yes, 3 and 14. And I'm surely missing one. Let me check. Yes. Oh, 6 and 7. Oh my goodness. 6 and 7. How did I forget about those? All right. 4, that's easy. Plus or minus. Oh, I almost forgot the plus or minus. 1, 2 times 2, and 1 and 4, and then 2 squared. Yep, that's it. Now, of course, we don't have to do a whole lot of work here. These are just all the possible zeros. But let's look at the calculator to see where the actual zero is. So this is where we graph it. Let's see, 4x cubed minus 27x squared plus 11x plus 42. Graph. Looks like there are 2 of them. Three of them. Oh, these are all real roots. I don't know why I'm surprised. We had done imaginary ones so long. So what they want us to do is they want us to find one of the zeros and then use synthetic division to get the other ones. So they want us to follow the process, if you will. So I'm going to do the process. So we got a 6 here. We have a fraction of some sort, and then we have, it looks like -1, which if you want to confirm for sure, you could just look here. So we have -1, that's where y is 0, and we got 6, 0. I'm not sure if there's a benefit to picking any one over the other. I'm going to use -1. That would be easier for me, at least, in my opinion, for synthetic division. So they want us to find one, so let's use the 0, -1. And we're going to divide this polynomial by -1 to factor it. So we have 4x cubed, so 4, -27, 11, and 42. We are dividing by -1. So bring the 4 down. That gives us 4 times -1 is -4. With the -27, that's -31. Times -1 is +31. Adding those together, we get 42 times -1 is -42, which is 0 as it should be. That is how we get, that's why it's 0. Oh boy, this is going to be fun. Okay, maybe I should have done a different 0, but it's okay. I'm still going to get my answer. That's what matters. Okay, so right now we have factored this polynomial down to x. This would be a plus 1, so I'd write that 0, times 4x squared minus 31x plus 42. You know what? I could actually factor it. I got this. I think I got this. Okay. So we're definitely going to want to use the slide and divide here. I will tell you, and you can tell by the calculator that these do come out decently. So you can use slide and divide here. So let's do that. So I need the ACB table to factor this down. So AC, what is 4 times 42? 168, and then we need 31. Okay, so I found the factors. They are 7 and 24. And also take note this is supposed to be a negative 31. So since this is a negative 31, that means both 7 and 24 are negative. And then you can see negative 7 minus 24 does give you negative 31. So I'm going to just bring this down as I go. We have x plus 7 and x plus 24. And then we divide by the a, so we divide by 4. And then x plus 1. This one we can't simplify, so we'll slide it. So we'll have 4x plus 7. This one we can divide, so we have x plus 6. And then that is fully factored. What do we need to do next? They want us to graph the function. They also want us to state the domain, range, and the end behavior. Okay, I like to graph last, so let's skip that. Let's do end behavior. So end behavior comes, again, from the very first original equation. We want that leading term, 4x cubed. The 3 is odd. The exponent's odd. Leading coefficient is positive. Odd and positive. Odd means disco. And then positive means we're going to move to the right because right is a positive thing. So this is disco right. That's our end behavior. So that means that it goes up to the right, meaning it starts negative. Starts negative, ends positive, goes up to the right. So that's our end behavior. Domain and range. Since we don't have any holes or anything like that to be aware of, it's not one of those problems, domain and range should very comfortably be negative infinity to infinity. The only thing of concern would be the range, but since this is in a disco problem, it goes up and down. There's no breaks in the range. Negative infinity to positive infinity. And again, this could be verified by looking at your calculator as well. Okay. I'm looking at the key I'm provided, and there's no graph here, so I'm not going to bother graphing it, because I really don't feel like graphing this one, to be completely honest. Okay. 16 is done. 17, basically repeat that process. List the possible rationals, zeros, p's, q's, find the zeros. I'm not going to graph it. And then state the domain, range, and end behavior. So we have x to the 4th plus x cubed minus 11x squared plus x minus, I don't even know where the x went, plus x minus 12. There we go. That's an x. Okay, so p's and q's. So this is our constant on top. So our constant's 12, and then our leading coefficient is 1. So that'll be pretty easy. Plus or minus, we have 1 and 12, 2 and 6, and 3 and 4. And then plus or minus 1 on the bottom. Let's reference our calculator to find the actual zeros. So we go in and we graph this. X to the 4th plus x cubed minus 11x squared plus x minus 12. Okay, so we see we have 2 zeros. That means we have 2 real zeros and 2 imaginary zeros, so we do have to find those by hand. Those cannot be found on a graphing calculator, I should say. So my 2 zeros that I'm given here are -4 and +3. So let's start there. So we're trying to break this down into its factored form. So we have x. Since this is a -4 here, that'd be a +4 on paper, as a factor, I should say. And then +3, that would be x minus 3. And then we need to get this bit here. And then to get that, to factor this down, if you remember, we have to use quadratic formula. So, to do that, we need to use synthetic division. So I'm still going to use -4 here. And remember, when we have 2 zeros that we find right off the bat, we have to synthetically divide twice. So I have 1, 1, -11, 1, -12. I'm just taking that for my polynomial. Okay. Synthetic division, bring down the 1. 1 times -4 is -4. Plus 1 is -3, times -4 is 12, minus 11 is 1, times -4 is -4, plus 1 is -3, times -4 is +12, which gives us 0, as it should. Now let's carry that on and divide one more time, this time by the +3. Bring down the 1, times 3 is 3, plus -3 is 0, times 3 is 0, plus 1 is 1, times 3 is 3, minus 3 is 0, as it should be. So our polynomial here is x squared, there's no x, plus 1. So I made that way too big, to say the least. So now, to solve this, we actually don't need quadratic formula since we don't have the 3 terms. We can just set it equal to 0 and solve. So, to get my last set of roots, set this equal to 0, solve for x. So subtracting 1, I get x squared equals -1. And then, remember, to get rid of a square, you square root both sides. This is x equals plus or minus the square root of -1. You should recognize the square root of -1 as I. So this is plus or minus I. So my roots, my zeros, are -4, 3, and plus or minus I. That is all of them. Okay. Then they still want us to do domain, range, and end behavior, so let's do that. So end behavior, we have x to the 4th. So we've got an even, and then it's like a 1, so we got positive. So that is up and up. So something like that. So it points to the positive infinities. The whole from the left and the right points to the positive infinities. So just for each habit of practice with the notation, they say x approaches negative infinity. You say f of x approaches infinity. Because this is just the left side of the graph is the negative infinity. And then the right side of the graph, as x approaches positive infinity, f of x still approaches positive infinity on the right as well. All right, domain, range, and end behavior. So the domain, we should pretty well be able to believe that it's still negative infinity to positive infinity. Now range is a little murky here because we know that our graph is going to look something like this, meaning it is going to turn around at some point. If you graph this, you can't see where the lowest point is, like on these, where the lowest one is. We can't actually see what these points are on the graph. So since we can't see those, we don't know the bottom of the range, but we do know there is a bottom of it. So I'm going to put a bracket, and then we'll put negative number to infinity, because we don't know what that number is, but we do know there is a lowest number because of how this doesn't keep going down, it keeps going up. So it does turn around at some point. So this is one of the first times where we really don't know our range, so we're just kind of going with it. Okay, number 17 is done. All right, back to some of the stuff that I prefer. Solve 4 plus 3i times negative 3 minus 7i. Multiply. FOIL. 4 times negative 3 is negative 12. 4 times negative 7i is negative 28i. 3i times negative 3 is negative 9i. 3i times negative 7i is negative 21i squared. So then we have negative 12. This is minus 37i, and this is minus 21i squared is negative 1. So this is negative 12 minus 37i plus 21. Lastly, negative 12 plus 21, that is 9 minus 37i. Remember, you have to have it written in that a plus bi form. Your answer choices will be written that way as well. All right. Number 19. Find the zeros of 11 equals 6x squared minus 13x. So, I was going to show you how to do this with the calculator, but as it would be, these are not nice on the calculator. So, we're not going to do that. We are going to have to use the quadratic formula. And these are not nice to factor either if you try. So, separate piece of paper. Number 19. 11 equals 6x squared minus 13x. So, to use quadratic formula, we need to put it in the form. So we need to move the 11 over here by subtracting. 0 equals 6x squared minus 13x minus 11. And then again, this does not factor nicely. Even if it did, I'm not a fan of slide and divide, so I'd probably use quadratic formula anyway. Reminder, you do have to have this memorized for the test. X equals negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. A is 6, b is negative 13, and c is negative 11. X equals negative b is negative 13, plus or minus square root, b squared is negative 13 squared, minus 4 times a is 6 times c is negative 11. And it's all over 2a, 2 times 6. I try to keep as much of this on paper as possible. I know a lot of you prefer to go to the calculator. That's fine. Just be careful with what you're typing in. This is a positive 13 plus or minus negative 13 squared. That would be 169. And that would be 44 times, let me see here. Yeah, 44 times 6. Ooh, I'm on the wrong part of my calculator. 264. And then that's over 12. 13 plus or minus square root. Add that to 169, so we have 433 over 12. Yeesh. Even if this does simplify, yeah. Yeah, I'm not sure. For me, it just kind of depends. I mean, it really depends on how your answers represent themselves in a multiple choice setting. So right off the bat, you know you can't divide 13 and 12. So even if you can factor something out of here, you can't simplify further from there. And this would be a pain to simplify. So I'm going to leave my answer like that. Reminder, your test is multiple choice, so you would have multiple choice options. So from there, you can kind of compare, did they write them as decimals, did they leave them, were they able to simplify it more? Those kinds of questions could be answered. So without knowing, I wouldn't really progress further. That's just me. We completed the assignment. Just find the zeros. These are our zeros. 19. 4 more. Using the graph to the right, what is the multiplicity at? Okay, this won't take long. X equals 5. This bounces. That's an even multiplicity. -1. Okay, I'm assuming this is -1. Goes through. That is odd. 20 is done. 21. Name the parent function and state the transformations of. These are old problems. Y equals 1 over x plus 7 minus 8. When we have the 1 over x, 1 over something going on, that's called the reciprocal function. Transformations. X plus 7, we read it as the opposite. So we would think of this as a right 7, but it's actually left 7. -8 is exactly what you'd think. This is down 8. And then B, this you should recognize as the absolute value function. And then transformations. So x minus 13. Again, it looks like a right or a left movement, but actually it's a right 13. And then the negative in front, that is a reflection over the x-axis. Reminder, you can always graph the parent function against the one here. So that would be y equals the absolute value of x. If you're not sure how it changed, you could always do that. Graph the original with the new and track and see what happened to it, how did it move. Same thing, the reciprocal function is just y equals 1 over x. Those orange sheets of parent functions, that feels like ages ago, that's what this stuff is from. So you should dig out that orange sheet and take another look at it. 22, they took away our multiple choice, so we can't cheat by using our calculator. Write the equation in vertex form by completing the square. F of x equals x squared minus 8x minus 17. We'll go to a separate piece of paper for this. 22, completing the square. F of x equals x squared minus 8x minus 17. First off, I prefer to use y, so let's replace it. Y equals x squared minus 8x minus 17. Add the constant over. Y plus 17 equals x squared minus 8x. Now we complete the square. That's where we add that term to both sides. So that term is b over 2. So I'm going to add it right here. B over 2 squared. B is -8. So -8 over 2 squared, which -8 over 2 is -4 squared. So that's what I'm going to write in the blank. Adding that to both sides. I didn't have a number in front of x squared to factor out, so I don't have to multiply something special over here like you have to do in some problems. You remember that step? Okay. From here, it's just simplifying. So the trick, if you do this part correctly, is then you can just write this as x minus 4, the whole thing squared. Simplifying, we have y plus 17 plus 16. This is y plus 33 is equal to x minus 4 squared. And then lastly, we move the 33 back over to the other side by subtracting, and we get x minus 4 squared minus 33. And just for good measure, I am going to graph the original and the new. These should overline each other on the graph. If they don't, I have made a mistake. And I'm genuinely checking this because I don't have the answer to this problem. X squared minus 8x minus 17 and x minus 4 squared minus 33. Okay, hopefully the red, yes, the red follows. Yes, that's correct. That's the right equation. They overlap perfectly. They have the same. This is my equation. So I'll write it on the paper. Y equals x minus 4 squared minus 33. That is correct. One more problem, and I don't mind these so much. Evaluate using the remainder theorem to find f of 2. So if I want to cheat, I could just plug the 2 in, get my answer, and move on with my life. I will do it the proper way this time. So what you're supposed to do is use synthetic division. So I have 1. I don't have the x cubed. I almost missed that. So that's a 0, negative 8, 10, negative 3. You're dividing by 2. Bring down the 1. Times 2 is 2. Plus 0 is 2. Times 2 is 4. Minus 8 is negative 4. Times 2 is negative 8. Plus 10 is 2. Times 2 is 4. Minus 3 is 1. So, remember the remainder is what you're supposed to get from f of 2. That's supposedly my answer. Let me plug the 2 into it now and make sure I get 1. If I don't, I made a mistake, which there is a very good chance that happened, because I am definitely not perfect. All right, so we have 2 to the 4th minus 8 times 2 squared plus 10 times 2 minus 3. 1. Yes, that is correct. And I'm done with the study guide. So as you can see, there is a lot to cover here. So really go through the topics, pick out which ones you think you're going to struggle with the most, and then you can definitely work on those. Definitely do that sooner rather than later, though. If you have any additional questions over the study guide, feel free to reach out to me via email or in person. Reminder, this test is completely multiple choice, so there are many things I've just discussed here that you probably won't even have to think about on the test. So just a reminder of that. And if always, you can make educated guesses as well. You can narrow down your options and then take a guess if you have to. So I wouldn't stress too much more about it than you already are. I'm sure you're feeling stressed out. I hope you're having an awesome day. I'll see you guys later. Bye.